Welcome, welcome. Day 2 of KubeCon, right before the lunch. Thank you very much for your time being here. We are very, very excited to be here. I'm Mathieu Benoit. I'm Cloud Native ambassador, and I'm also a customer success engineer at Humanitec. I'm very excited to be with Max today.
Hi, everyone. My name is Maxime Coquerel. I'm a cloud security architect, and very glad to be here with you today. Before to start this presentation, just a quick disclaimer. Any view or opinion expressed in this presentation are only my opinion and not necessarily represent the opinion of my employer, its management, or its employee.
So, Max, you remember when I started my journey, I was app developer. And I started my journey as kind of platform engineer a few years ago. And when I ran Docker Run, the first time it was like, what, amazing. Like I was very mind blown. Then I discovered kubectl Run. Wow, okay, I could do more stuff in my Kubernetes cluster, right? And then I discovered Helm. And I did Helm upgrade, and I was able to deploy easily something more complex. And then I tried with Terraform Apply. And as a developer, I was like empowered. I was like very amazed. But actually, it's way more than just running this command, right? Could you elaborate a little bit more?
Exactly, Matthew. You know, as you know, security in the cloud native world is something of very complex, or sometimes very complicated, very challenging to understand. Just check the CNCF landscape, you know? You can see the number of products, the diversity of products. Some products have some gaps, some overlap in terms of feature. And it's also very challenging to find the right product for the right use case if you are not a familiar user in this case. But now, if we step back, you know, let me talk about security governance, because that is a foundation. The foundation of a cloud security team. And you know, if you want to be able to scale in your organization, you have no choice to have a right framework in place. And a lot of organizations, specifically the regulated organization, follow this framework. In the first step, we will have what we call a security review. What is a security review? In reality, it's a technical document where we will highlight all the security capability of a specific cloud services. For example, Azure Storage Account or AWS S3. We will also identify, you know, which security control we need to create to be sure the service is deployed from an hard way. And also, we will also identify which potential threat we can have if we use these services with misconfiguration. In addition of that, the next step is to do threat modeling. It's very interesting and very important to do threat modeling in the early phase, you know, in this case. A threat model, for people which are not familiar with that, is like a mapping of the different components of your architecture. And the goal of that is to identify if we have any missing security control, any threats which are not covered, you know. And that will help you to be very proactive and give an early feedback to your developer versus to wait to be at the production gate. Next step is cloud control validation. Because as you know, regulated organization, we have no choice to follow regulated standard. And what we want to adopt is to be sure we have all the best practice in place. And for that, we are conducting cloud control assessment. A lot of organizations are leveraging the Cloud Security Alliance matrix as a baseline for their cloud control validation. Next step is pen test. It's very important to have pen test, specifically if your application is exposed to internet, because you want to have a third-party opinion about that. And you know, all these 4 steps, you know, that will feed what we call a scorecard. A scorecard, it's an IT risk document which will define the security posture of your application in the cloud. And you know, this scorecard should be in correlation with the risk appetite of the organization, just to be sure everyone is comfortable with that. And the scorecard is often presented during a cloud governance board, where you have the chief architect, where you have the chief security officer. Without to have a framework like this one, it's very, very challenging for an organization, specifically a large organization with regulation, to scale. And to help us to do that, the CNCF created this 4C security model from code, container, cluster, to cloud. That can help you to map your different security controls, the different tooling you need to have in place. Just, I want to give you some example about some potential Kubernetes security challenge. We are very lucky because our friend from the OWASP created this OWASP top 10. As you can see, we have then more 10 biggest security challenge. One big security challenge is identity. Identity in Kubernetes is something very critical, very complex. A lot of organizations have a lack of identity monitoring. And you know, if you want to address that, a lot of tooling exists today. And you know, to give you an idea about the different security threats you can have against a Kubernetes security deployment, Microsoft created this threat matrix. That will give you an idea about which attack an attacker can use against your Kubernetes infrastructure. As you have seen now, cloud security is very complex, you know, specifically in the cloud native world. But for that, we have an answer. And the answer is platform engineering, and Mathieu will present you that.
Yeah, because Max, stop. It's too complicated. We got the feedback that we are blocking innovation for our developer. And we are like limiting how we could deliver value for the end user. And at the end of the day, our company needs to make money, right? So how we generate that? And the happiness of the developer are not good. We did a survey, and they are like complaining that security is just on their own responsibility. So are you helping them, Max, or with that? I understand it's important. So what we are driving now, it's this kind of initiative around platform engineering. And platform engineering, again, is not new. Don't make me wrong. But what I really love about platform engineering is it's taking experience, learning from the experience, from a sysadmin world, a DevOps world, and getting together best practices. More focused on what we call building an internal developer platform, how we could improve developer experience, right? So that's what we want to discuss today, shifting down to the platform instead of shifting left to the developer. And we want to start with this need. The developer are asking us to make sure we simplify their life. They want to focus on their code and not doing infrastructure, not doing security, not doing Kubernetes if possible. On the other hand, we want, the platform team, we want to make sure we have standardized recipes. We have more automation, how we could put that together. And actually, I'm not a brand new team reinventing the wheel, replacing those guys. They are very technical. So what we are doing with Max as a security expert, we are combining forces. We want to put together all this automation, the tools, and we want to add more abstraction. Again, there is tools and frameworks, the CNCF platform working group put together some white papers, and building an internal developer platform, it's all about building blocks and existing teams, existing tools you have, right? Now the goal is picturing these building blocks, making sure you understand the interaction between tools, between people, the processes, and now you may want to optimize how we could save time, how we could remove friction between them. Because again, as a developer, I don't want to know what is at the bottom of this slide. And platform engineer will need to orchestrate maybe, or facilitate the integration of security engineer, cloud engineer, network engineer. What is very important for this platform engineering initiative is also to see your IDP as a product. You have customer, and maybe you have multiple customers. I love this, this quote from a LinkedIn post caught my attention. And it was security expert, and they said, yeah, we need to evolve. We are security engineer, but we need to have this mindset of a product decision and not just technical engineering detail job, right? And that's very important, right? Try to resolve pain point, focus on your customer and all your personas, not just the developer. many other stakeholders. You need to have a backlog. You need to have a product manager, a product owner, and maybe multiple people on that. And you need to focus not just on tools. We will discuss a lot about the tools today, but please take this slide very seriously because we are not focusing on this, but that's very, very, very important. Let's now share some tips. We want to start with, on a developer perspective, what could be improved? We have heard, we have listened, some feedback, and we want to focus on this interfaces maybe, between them and our platform, our internal developer platform. So, as tip number one, we have seen a huge benefit of using this kind of project. I don't know if you're familiar with all of them, but the goal is to abstract as much as possible while having our developer in their inner loop, right, locally, being very productive. So if you know Buildpack, maybe you want to abstract writing Docker files. That's a good example. Another one, I don't know if you're familiar, Dapper. They won't interact with Redis directly or with an infrastructure in cloud directly. They will contact a Dapper client. So they will have an abstraction on what they are talking to in terms of infrastructure. Microx, mocking API could be a good benefit to avoid integration tests too late in the pipeline and maybe having some tests shifting left this test locally. And Score, in order to abstract the deployment for the platform, that's kind of some tools you may want to look at for your developer to help them being productive, staying in their inner loop, without having all this integration pipeline or test later in the pipeline. Tip number two, how you could provide self-service. How they could get the centralized, maybe technical documentation. Do they have multiple places to get a documentation to accomplish something? Could you centralize that? How they could onboard on a new project, on your new platform? How you could provide also a view of the different system. Maybe they need to connect, they need to switch context. How you could reduce this cognitive load on a centralized place. And if you are familiar, maybe, with Backstage, that's something you could look at. There is other portal framework and tool out there, but that's a very, very popular one. As tip number three, very popular recently, if I could say, how you could interact with the platform and the tools, because we got the feedback. Max, Mathieu, that's good. You abstract as much as you want for your developer, but I'm receiving a lot of Slack message, personally. I'm receiving a lot of Teams, ServiceNow ticket, Jira ticket. How you could empower them and shift left on how I could query maybe some systems. So you will have and you will design what could they get, right, to enhance the education. Can I have the status of that, the log of this, why this and why not that? So with that, you could reduce the ticket ops and increase the visibility for them. And not shifting down the cognitive load on security, cloud engineer, Kubernetes engineer as well. Now, we want to highlight some tips more for the platform engineering and security perspective.
Okay, perfect. Thank you, Matthew. But now, if you remember my slide with the 4C, from code to cloud, we will go more deep about that. What is a very good and best practice to do is to do infrastructure as code scanning, and also to do source code scanning, because you are all aware about the number of CVE we have across all the dependency, all the library. You need to do that in the early stage. For that, you can leverage tools like Checkov, Kix, for example. Next step is a container image scan. A lot of people are doing container image scan. That is right, But in addition of that, what is very important is to sign your container, to be sure you have the right container, only the container you allow running in your Kubernetes cluster. I know that could be sometimes challenging for large organizations, but that is a very best practice you should to put in place. In addition of that, and my favorite part is compliance control. or you will prevent misconfiguration, or you will prevent configuration drift in your Kubernetes cluster. For that, you can leverage solutions like OPA Policy Agent, Kyverno, for example. And in addition of that, runtime security monitoring. As you know, it's good to have your workload, but it's better, if you can monitor the behavior of what happened inside your different workload in your Kubernetes cluster. Maybe you have one pod which try to talk with a malicious botnet, and you want to be notified about that. Or maybe you have another pod who try to do like lateral movement, and one pod maybe can compromise, the node, and from the node move to an lateral movement to the cloud provider and compromise all your entire cloud infrastructure. And that is very important to take that in consideration and monitor that and be able to react to that. I wanted to give you an example about distroless. Distroless is also a very good security practice to adopt. Not a lot of organizations are doing that, but I will invite you to do that, because with distroless, what you want to have very small container image, because if you have a very small container image, that means your attack surface is also very small. You have less CVE to maintain, less vulnerability, and by the way, you are more secure to that. And you can use solutions like ChainGuard, for example. Now, we will talk about prevent misconfiguration, what I have already highlighted before to you. But before that, I want to take the time just to highlight we have two types of security control. In this case, we have cloud vendor security control, like Azure policy, AWS config, GCP security organization policy. That is a security control you apply at the cloud provider level. But that is not enough. In addition of that, you need to have Kubernetes security control to prevent, to have container running as root, to have a container with extensive privilege, for example. And for that, you can leverage PSS, OPA Gatekeeper, Kyverno, gsconfig. A lot of solutions exist in the market. Please find to take the right solution for your organization, and be sure you have this security control in place to have an hardened Kubernetes cluster. Now, about security control. As maybe you already know, we have three main types of security control. We have detective security control. That sometimes is the first step. When you deploy a Kubernetes cluster, you deploy the security control as detective. That means that will only inform you about what happened. The next step is preventive security control. In this case, is we will block what happened. From my experience from day one, I will recommend you to deploy your cluster with preventive security control, because it's very challenging to switch from detective to preventive. And after that, we have auto-remediation security control. When you have a misconfiguration, to have an automatic task or an automatic script to fix the misconfiguration. But that is not enough. What we wanted to do is to give more power to the developer, more flexibility, because this security control are deployed at the cluster level, and the developer is notified only when he tries to push a workload to a cluster and at the cluster gate, and that is not enough. And for that, it's very important to give early feedback. And for that, we can have directly security control in the IDE of the developer. But it's still not enough. I will explain you why. Because a developer will receive a message, hey, your deployment will block because you have a container as root. But now you need to educate your developer. Education is a key point of the success. And, as security team is sometimes challenging because we can't scale, to spend hours and hours to educate developer. And for that, as Mathieu mentioned before, we need to have a self-service model. And EI agent, that could be a solution to give more context to the developer and more best practice to follow and sample of code, for example, to resolve the misconfiguration. I wanted to just show you an example of pod security standard policy. That is something you can leverage for very simple use case, and if you start with Kubernetes, but for a lot of large organizations, that is not enough. And the reason of that is because you want to have more advanced complex use case. Sometimes you want to manage exception for some specific use case. And for that, I will recommend you to choose a solution like Kyverno or OPA Gatekeeper, for example.
Wonderful. Max, we have seen a lot of tools. That's beautiful. And what we decided all together is, as platform engineer, how we could make sure we could shift left the detection of the error, but not asking the developer to maybe run the command and leverage the tools. So here it's a very busy image, but that's to show you where maybe all these tools could fit. And we decided to have templates. We are using GitLab, GitHub Action, Jenkins, multiple tools, and we will have recipes, template, reusable for our developer in order to having more tests and failing fast as soon as possible in the pipeline, not waiting to deploy in the CD part, but maybe in the CI part, continuous integration. So that's where we have, for example, running a container in my CI tool. Is it running? If it's not, failing, and providing the rapid feedback to the developer. Can I scan your dependencies? Can I scan your container? Can I also check some configuration? And I will fail on the CI part. I'm not even deploying something here. And then moving to the stack and the workflow. And here we would like to have more control as well in the cluster, in the continuous deployment pipeline as well. The idea of that is, as platform engineer, we have a responsibility to abstract all this kind of complexity and failing fast and providing the feedback earlier. Tip number 7, what we have seen is where we failed in the past was taking Kubernetes as our platform. Actually, Kubernetes is not a platform. Is something to build a platform upon, right? And that's where, as a reference, Daniel Bryan did this talk. And here, in the industry, you could look at these different tools and the notion of orchestrator, how I could orchestrate on top of Kubernetes, maybe orchestrating some cloud resources, Kubernetes resources, right? And how I could abstract and having a layer on top of Kubernetes. So I highly encourage you to consider looking at them. Tip number 8 is we got a lot of concern about how my workload, when running somewhere, will connect to my cloud SQL database in my cloud provider, right? Here it's an example with AKS Azure, but it's working with different cloud provider. There is also some CMCF project helping for that. The idea is to go keyless. How your workload will connect. They don't need a long life token to connect from the workload to the cloud provider. Maybe you want to leverage such mechanism with OIDC, providing a short life token and having this role-based access control using the least privilege concept as well. But that's a very convenient way to not block and having issue with rotating key, etc., etc. And we have seen 8 tips today. There is more, and maybe that's a lot. The key secret is all about starting small. You need to study what are the pain points, what are the parts you could optimize, what you could achieve, and have this kind of backlog, right? So we have seen how we could having our developer more productive, having this velocity in mind. And what we want as platform engineer is having stability and making sure we are staying compliant. But we don't want to block innovation for the developer. And what we are developing is this product mindset. Very important. With that, we could have investment, priority, making sure we have this seamless integration of the different key tech stakeholders. Some takeaways. The security could be seen as a culture, right? And not just tools or people blocking innovation and creativity. And combined with this platform as a product mindset, that's what we have seen very successful. So embracing the security first approach is very important. How we could empower people, empower this platform engineer, understanding better the life of the security people, and also making sure we could optimize, standardize, and abstract from the developer.
Yeah, maybe if I can share feedback about that. One point which can be very successful if you embedded your security team directly in the engineering teams, in the platform engineering teams. They need to work together from day one, and not to, in this case, that will change the mindset of the security people, of the platform people, of the ops people, and work together, work to have the same goal and achieve that together. If you increase the communication, that will be better for everyone. Trust me.
Cool. So we want to call out all the resources we have been collecting and we have used for the slide, CNCF tax security, app delivery as well, and some other blogs articles. So please look at them. The PDF format of this presentation is already on the schedule. And you could also please evaluate this session, share your feedback. We want to improve this presentation. And there is a slide as well that you could download. We hope you enjoy the content of this talk. Please come by, share your question, concern, own experience as well. And we wish you a good rest of your KubeCon. Thank you very much.
Thank you.